All right, guys, since we didn't have a chance today to have you clearly understand what I was saying, I thought I'd go ahead and make a recording of what I was talking to you about. So we're going to start simulating in Tinkercad the electronic circuits we're going to make in Arduino, okay? And here are some of the basic parts for this particular one. We have a battery, we have some wires, we have a resistor, and we have an LED light, light emitting diode. That's what that stands for. The battery's there because we need a source of power to make anything that involves electricity actually work, right? We need to make it go on. Every circuit has a positive and a negative side, and when those are connected, we have something known as a complete circuit. If the circuit is incomplete, it does not work. If it is complete, it powers on, right? So when you turn off the light in your house, the circuit is incomplete. When you turn it on, the circuit is complete and the light comes on. Okay, same idea here. So because the circuit is complete, you can see that the light is blinking. Okay, or not blinking, it turns on. Now, here are the parts. In a light emitting diode or an LED, you have a side that's called a cathode. A cathode is the negative side, okay? The anode is the positive side. You'll just have to remember that. Okay, so positive anode, negative cathode. The negative end of the cathode, okay, of the LED light is connected to the negative end of the battery. Okay, so negative to negative. Okay. The positive end of the anode is connected to a resistor, which is then also connected to the positive end of the battery. The reason that we need to have a resistor is because there's too much current that comes from the battery into the LED light. And as a result, without the resistor, it would blow. Okay. So that's the reason we have to have that there for it to work. Otherwise, if we were to say, take that away and just connect it directly like this, oopsie, and we hit the simulation, of course, now it's going to work on here. Generally, what should happen is if right here it says current through the LED is 61.9 mega amps or milliamps, while recommended maximum is 20. The usable lifetime of the LED may be reduced. So we are putting too much current through there, okay? And in some cases, if you had a higher voltage battery, this is only 3 volts, it would blow the entire bulb, okay? So let's put a resistor in. We're going to change the resistance to 220 and ohms. That's how resistance is measured. So 220 ohms. We're going to put that here. I'm going to actually here and here. And now we're going to reduce the voltage, or we're going to reduce the current that's going to the lamp, and it's going to make it a lot better. And we don't have to worry about it blowing. Okay. So those are the parts of the circuit that I wanted you to understand today. And let me know if you have questions. Thank you so much.